In this video, we're going to take a look at design patterns in Java. We're going to look at the Gang of Four's 3 different types of design patterns. And actually in this video, we'll be looking at one of those 3 main categories. We'll be looking at the creational design patterns in Java. There's also behavioral and structural design patterns. However, we'll come to those in separate videos. So essentially, a creational design pattern is something that focuses on object creation. So there's 5 key patterns that we're going to take a look at in this video. We're going to first have a look at the Singleton pattern. So the Singleton pattern, it ensures a class has only one instance and it provides a global point of access. So let's have a look at that. So if we go to the Singleton simple cache Java file, here we can just have a little look at some common use cases of the Singleton design pattern. And in this video, I'm going to be mainly looking at applications in web development. So one of the most common applications of the Singleton design pattern is database connection pools. You can also use it for logging mechanisms or shared configuration settings or thread pool management or cache management. Essentially, it's just a global service essentially, or a global class that we can make use of throughout our application. However, it will only create one instance of that, and we'll see why that's important in just a moment. So what we want to do, there's 2 key considerations that will need to be implemented when considering a Singleton and the Singleton pattern in general. The first is the use of a private constructor. A private constructor is used to prevent instantiation. So in the private constructor, we will just set the cache here. So we basically create a static variable which is of the same type as the class, and that's going to be called the instance. So what we can do is we can essentially, when we create our Singleton, we can just go ahead and we can, we have this private constructor, so they'll just set the cache to whatever it is when it first gets called, from wherever it gets called from. But we also have this method here, which is get instance, and all it does is it just checks if the instance is null. If it is null, we return a new instance. Otherwise, we return the existing instance. And one thing you'll see here is we actually have this synchronized keyword, and that might be a new concept to you. So basically, what this all means, and I have some notes here that go into more detail, but essentially it's possible if you have a Tomcat server that there will be multi-threaded processes occurring at the same time. So typically if you have a web server, it might spawn more threads for each incoming request, or if you have a database connection, it may create several threads to handle the database operations, and you might also have background tasks like timers or scheduled tasks. And in addition to this, there's also some system things that happen with the JVM itself relating to garbage collection and other internal tasks that make use of threads. So basically, you could imagine if you had a web server and you had multiple requests coming in and they're spawning their own threads, you'd want to make sure that that class that handles that is accessing something that is going to be consistent with itself. So essentially, what happens when we use this synchronized keyword is it ensures that only one thread can use a method with the synchronized keyword at a time. So if we had 2 requests coming in at the same time, behind the scenes, one will be in a queue or something like this, and it will only allow for one of these interactions to occur at a time. And you can imagine with things like the database connection in particular, you want your database to be what it should be. We don't want any weird stuff happening, and you don't want any weird stuff happening in general. So in this example, we've got this cache management implementation. It's just a very simple in-memory cache thing that we're doing here to demonstrate the Singleton design pattern. But the whole design pattern basically revolves around having an instance of the same type as the class, a static instance, and checking whether that's null or not. If it is, you return the new instance, otherwise you return the existing instance. So you can imagine, once again, if you're accessing database connection in different parts of your app, well, you wouldn't want it to connect over and over again. You just want to use the shared pooled connection. And likewise with the cache, if you have like an API, let's say you have a Spring Boot application, you wouldn't want to if you want to make use of the cache in all different sorts of API calls all throughout your application, and you want to make sure that that cache is consistent with itself across the threads. So that's how the synchronize keyword impacts methods, and you can also use it inline and stuff like that as well. So then from there, we just add 3 different methods here. So put, get, remove. And all we're going to do is just put some key and value into a hash map and return that or remove that. So let's take a look at the use case of that. So here, what we're doing is we're creating cache, and I've also created a second cache. And one thing to note is in the constructor, private constructor, I'm just logging out initialize cache. And this is just going to help us demonstrate that it actually is only occurring once. So then we're going to add to the cache, and then we're going to add to the cache too, but it's all the same cache. And that just ensures consistency throughout our application. Then we're just going to get a few things and delete something here. And then we're going to try to get the deleted user 1, and then it should be null. So I'm just going to go ahead and run this, and I'm using Docker, and it's a very simple Docker file. You can just get it from the GitHub. So I'm just going to build this, and all it is it's just a Java 21 server. I didn't want it to clash with my Java versions on my computer, but if you have Java on your computer all set up nicely, you wouldn't have to do that. So let's just go ahead and run this. And we can see that the initialize cache only gets called once. And it doesn't matter if we use cache 1 or cache 2, the user will be created to the same in-memory data structure. And we can retrieve the user from the cache, either of them that we're selecting, even though it's only one under the hood. And we just remove the cache entry, so we get a retrieval of null there. So that is the Singleton design pattern. Let's next take a look at the factory method design pattern. So the factory design method, it defines an interface for creating objects, but lets the subclasses alter the type of created objects. It promotes loose coupling by delegating the instantiation process to subclasses. And it encapsulates a group of individual factories that share a common goal, allowing for easier management of related object creation. So actually, I think this actually belongs to the abstract factory. Let me read that again. Encapsulates a group of individual factories that share a common goal, allowing for easier management of related object creation. Okay, so just ignore that for now, but with the first part there, what we'll look at is we'll look at the factory method in action. So it will make these definitions will become clearer as we get into it. So let's just take a look at the factory method here. So let's have a look at some common use cases here. So a common use case is a database connection factory. Let's say we had different types of databases that we're connecting to, but we wanted to, connect to it in a similar sort of fashion. Likewise, if we're giving back JSON or HTML or different types, we could have a HTTP response factory. We could have a logger factory, which gives back things for the console logger or the file logger. We could also have a request handler factory, so handle GET requests or POST requests, and so on in different ways. And we could also have the validator factory. And this is the thing we're going to take a look at. So it says here dynamically creating validators for form fields. So email and password is what we're going to take a look at. So we'll come back to this here. It's just basically what we want to do is we create an interface, iValidator, which will have the Boolean method validate on it, which takes the string value that you'd receive from a form. And then we'll go ahead and implement that for the email validator. And we just override the class. So we can validate that string. And basically we're just doing simple validation. If the string contains a @ symbol, well, that's good enough for us for this purposes. And we just got another password validator here, also implements the iValidator, which also overrides the password field and just checks that the length is greater than 8. So all this really does is we just basically have a switch statement here, or in this case we've got an if-else-if here, because all we do is we create a validator and we specify the specific type. So here we've hard-coded email or password. You might want to have enums or another way to organize this. And then what we do is if it matches the particular validation string that we're looking for that represents the validator, we return the particular validator, and that will have its own overrides in the subclass. So just to look at that in the main method here, we create a factory method here. So here we have a email validator of type iValidator, which is the factory method validator, which is where we can select between the two based on the type that we pass in for the field type. And let's say we create a validator for the field type email, then we can make use of that email validator's validate function. And let's pass in this email here. We can check if it's a valid email or not, and then we can print it out. So we do the same thing for the password validator. We use the factory method validator class once again, and we can use the same method, create validator. However, this time we pass in that the type is going to be a password. And then we can once again, since we're using the same interface, call the validate method, and we can pass in our value, and then we can check that that is indeed valid. So let's go ahead and just rebuild things here. And I'm just going to run that as well. And you can see that it's got our cache stuff going on up here. But here we can see at the bottom here, email's valid and password's valid as we expect. So the next thing I want to take a look at is the abstract factory. And the abstract factory provides an interface for creating families of related objects without specifying concrete classes. And I believe this part here should be there. It encapsulates a group of individual factories that share a common goal, allowing for easier management of related object creation. So let's have a look at that. So actually I might close the Singleton and the factory method files. And if we take a look at the abstract factory, firstly, if we just look at some of the common use cases of this in web development, we can see that it can be used for an authentication mechanism factory, and that's what we're going to do, and we'll see that in a moment. You could also use it for a cloud service factory or a message queue factory in a microservice architecture based application. So since it also has the name factory in the name, I just want to make sure that we're not getting confused between a factory method and a abstract factory. So the factory method, it allows subclasses to override the method to create different objects, whereas the abstract factory, it provides a way to create a suite of related objects through its multiple factory methods. So let's take a look at some use cases. So we could use the factory method when the system needs to be flexible regarding the instantiation of a particular product. But we could use the abstract factory when the system needs to ensure the products it creates are compatible with one another. So that's sort of in line with this group of individual factories that share a common goal for easier management of those related object creation. So let's actually look at the example here, and we can see that we got this auth abstract factory class interface here, and all it's going to do is it's just going to have this interface authenticator, and we're going to have a method here called create authenticator. So if we look at the interface here, we'll see that we have a authenticate method here, and there's a override for it. So, well, there's a method with the same name with a different signature, and that's totally fine to put those details in here. That's perfectly acceptable part of the design pattern here. And essentially we're putting the code in these files here, but then when we use it in main, it will make things a lot nicer for us when it comes to using the same interfaces across classes of similar objects, and we'll see that very shortly. So what we'll do is we'll just take a look at two different methods of login. So we're looking at authentication, and you can imagine you could log in with a username and password, or you could log in with social media or OAuth, for example. And with OAuth, you could do it with a token, but email and password, you might do like this. So let's take a look at OAuth. So we need to implement the authenticator interface. We need to override both of the methods. And as I mentioned, this one here could just throw an error. It's not meant to be used by the programmer, and perhaps throwing an error would be good here. However, it's perfectly fine to have this because it fits in with the design pattern. Just, tucking this method in here just hides those details, but it ensures that we have similar interfaces that we can use. So here we just check the token, and if, say, the token is equal to some valid token, obviously you would have your logic here to will return true or false. And likewise, we have a username and password, and if the username equals admin and the password equals password123, we'll say that that's a valid authentication. Obviously, you would have your logic there once again. And again, we have this override for the other method, which won't be implemented for this particular class. So then, since we have that, we can actually have the factories. So we have two factories. We have an OAuth factory. So that's going to implement the abstract factory, which essentially will just have this create authenticator method. which returns an iAuthenticator. And then we can return the new OAuth authenticator. So just to chain through that for OAuth in particular, we have this abstract factory. So this is just an interface with a method on it, create authenticator. And if we go into iAuthenticator, it has those methods that we also need to implement. So that's also an interface. So if we look at OAuth, we can see the actual implementation of those methods. And if we look at the factory, we can see that if we call that factory, it's simply just going to return this here, this class. So that's going to be very similar with the username and password. It does the same thing. And if we go ahead and we go to our main file here, we can create our abstract factory here. Now, I'm not sure if I actually showed the password before. True, oh yes. Password is valid. So username and password. So let's do it for username and password, and then we'll do it for OAuth, and it's the exact same steps. You just use the abstract factory interface, and notice how they're shared between the interfaces are shared for the same steps in either the username login or the OAuth authentication. So in this case, we can just create a new username and password auth factory. Whereas in this case, we create an OAuth auth factory. But we can do it like that now because using this abstract factory auth interface because of the way we've set up this design pattern. So the abstract factory allows us to do something like this, where we can, if we want to get the, for the particular factory that we're on, so for this username and password email authentication factory, we can create the authenticator. So we create this iAuthenticator here, and we can just go ahead and authenticate with, say, admin and password 123, which we know will be all good. And we can print out if it's validated or not, or authenticated or not, I should say. And likewise, we do the similar thing here for authenticate here. Same method, name, different number of parameters here, but we have the consistent types for these related things. So the factories, the abstract factory here, these are related factories via the fact that they're both related to auth. So we want to have similar types for that and share some of the similarities between the two. So if I just go ahead and save that, I could once again do a Docker build. And a Docker run. And we can see here that both the username and password and the OAuth authentication have came back true. Okay, so let's close those. And let's take a look at our next design pattern. We're going to take a look at the builder class. So the builder class, it creates complex objects step by step without the need of a constructor that takes many parameters. So if you've seen something like jQuery before, where you essentially turn the class each time, and then you can just add on methods to it. So in jQuery, you select the DOM element, but then you might add a class to it, and you can just do that by tacking on methods. So we'll take a look at this. And for this example, I might actually show the use case first. So just to show you what the code looks like. we create this new object here, but then we can just set things. We can set the host, set the port, set the username, set the password, set the database name, and then we can build the object. And the way that works is this set host method and all these setting methods return the actual instance of the object. So you can just tack on things. So that's a pretty common method you might see in different situations. So let's take a look here. So common use cases is creating and building complex objects, configuration of database connections, and HTML response generation, among other things. So here we're going to take a look at database config. So basically we got two classes. We're going to have the builder database config and the database config builder. So basically, if we look at the usage of it, we see that we have the database config here, and that's being returned from the build method. So all these sets here are returning this, but then the build method is going to return this object here. So just to show you, on the build database config, we're just going to have all the properties and all of these getters and setters here. And all we're doing is just basically we're going to pass in a private constructor, which will be called by the builder, the database config builder file. And then what we're doing is we're using all of those properties that are on the builder to set the properties on here. And then what we do is we do a system out, we print this, and when we print it, we have this override here. So rather than printing the class, it's going to do this toString thing, and then it's just going to print out the host, the port, the username, and the database name. So one thing that might look different to regular, plain old Java objects is this private constructor, which has this database config builder in it. Well, I guess it's public here, but you get the point. So we have the database config file. So this also has those properties there, but this one has all the gets on it, and this one has the sets on it. So every time you set something, we're just setting this property on the builder, and then we're returning this. And that allows us, so as you can see here, we create the database config builder, and then we can return set host, and that's also going to return a database config builder. And we do all of that, and that's at that stage it's still going to be a database config builder, but it's actually the build method that's going to, if we scroll down here, we build and then we return a new instance of this class here. So essentially, let me just make this private here. Oh, actually, yeah, that's right. Okay. Maybe I'll just edit this note here. Constructor be called by the builder. So yeah, we create the database config builder. We set all the things. We return that database config builder object. And then after we're happy, we can just go ahead and we can call build. And we can call a constructor with this builder. So we just pass in this. So this refers to the whole instance of the object with all the things set on it. And that's going to come into the constructor here. And then we're just going to set all the properties here like that. So that is in essence the builder property. It's kind of just makes your code tidy. So let's just take a look at it. So we see that we've got this printout here, localhost 5432, maybe it's Postgres, got your admin and your database. Okay, so the final creational design pattern that we're going to take a look at, and the only ones from the main, so there's only 5 that come from the main 23 design patterns from the Gang of 4, I'm not missing any. But the last one is going to be the prototype. So this creates new objects by copying an existing object. So you can imagine that, you know, you could get into a situation where you need to take a copy of a complex object. And that's what we're going to take a look at in this video. You could also use it for state restoration. So, you know, if you've got undo or redo in a web application, you need to copy something, and then you can easily revert by cloning the appropriate prototype instead of reconstructing the entire object from its components. So you could imagine, because you know that objects, they're not primitive data types. So when you reference them, there's like a pointer to it. And if you wanted to create another one, you need to clone it rather than just pointing to it. Otherwise, you'll override the original. So what we do here is we just create this interface here, prototype clone object. And notice that the interface is the type here for the clone method. And then we just take a look at the concrete class that implements it. So we have the book here, just as an example, with title, author, and pages. We just have the getters here, and we're using the constructor to set things. So all we want to do is we want to have a clone method here, and it's going to create a new book. And we also have this override for toString, which will just spit things out for us nicely. So let's take a look at this. We have an original book. So we've gone with 1984 by George Orwell. We've got the number of pages here. And then we clone the book. So we take the original book and then we clone it. And we can print these out. And what we do is we verify that they're different objects, because if they were the same, we would get true for this original book equals the clone book, because we'll just be pointing to the same memory address. So let's go ahead and just do a Docker build and a Docker run. And we can just see that both the books are not the same. So we've successfully made use of the prototype design method, and we determined that we made a clone of the book without any issues. So they're the main creational design patterns with a focus on web development use cases. So in the next video, I'll probably take a look at the other types. So we got behavioral design patterns and structural design patterns. Make sure you subscribe to my YouTube channel, and I'll see you in the next video. Cheers.